All right, we continue the journey with binomial distributions. This is example 4, part B. And again, I would suggest you watch these in sequence. We've surveyed 15 people. Each of the 15 either flosses or does not every day. The question mentions flossing, so again, that is success, which we were told was 59% of our population, which means the other 41% do not floss every day. All right, so in part B, they're asking us to find a probability that the number of people out of the 15 that floss every day is at most 2. So if we look at the numbers from 0 to 15, because again, if you survey 15 people, anywhere from 0 to all 15 could be people who floss every day. But when it says at most 2, I hope you would agree that that would be all the numbers up to and including 2. 2 at the most. So that's not exactly 2 of the 15. It's up to and including 2, at most 2. I'm not an English teacher, but you get the idea. So what math symbol would we use to say that the number of people who floss is at most 2? How about less than or equal to? Exactly. Mr. Salamander is very happy that you knew that. Less than or equal to 2, up to and including, all right? So what I do when I see a question where it's a range of numbers that satisfy the question, here's what I think through. I'm lazy, all right? What would be less work? Should I set up the probabilities for 0, 1, and 2 and add them up? Or should I find the probabilities of the opposite, the complement? Nah, the opposite would be more work. I think I'll just do the original question. I think I'll set it up for 0, 1, and 2. So here we go. Equals, let's do 0. Let's start with that. What's the probability that 0 of the 15 people floss every day? Hey, I'll give you 15 people. You can choose any 0 to floss. You're going to have flossing 0, right? Nobody in the group flosses, which means that all 15 of them do not. There you go. So you got no flossers and 15 who do not. And then you crunch that out, and that'd be the probability of 0. Put a check mark next to 0. That's that one. Or, that's why this is plus, so you're going to have 0 people in the group that floss, or you're going to have 1. All right, let's set that up. We have 15 people. Choose one of them to floss, which floss, I want to remind you, is 59%. One person flosses, which means 14 do not. I think we've got the pattern established from previous examples. That would be the setup for 1. Or, and then that will do 2. I'll give you 15 people. You can choose any 2 of them to floss. Flossing, which is 59%, there'd be 2 of those, which means the other 13 do not floss. 2 flossers and 13 who do not. And that would be the probability for 2. Crunch, 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 write it down. Crunch, 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 write it down. Crunch, 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 write it down. Add them up. All right? You know how it is? I've told you on the previous examples that the crunching is mechanical stuff that we talked about prior to spring break. So just for the record, I'll put the answer up here. That should end up being, after you do all that button pushing, and again, you can practice this on your own. I want to remind you too that you can do the practice problems that I've uploaded. And what you should get for this answer should be something like 0.000037325. You know, if your numbers at the end are a little different than mine, that's just a difference in calculator. Don't sweat it. But if you can show me the setup here and push the buttons, my hope would be that you would come up with that result. All right? So that's example 4, part B. And we'll just continue the journey here.